the wood that refuses to rot. Black locust sits at the center of this story, and what makes it stand out comes down to its natural resistance to decay, because unlike most timber, it doesn't depend on chemical treatments or protective coatings to survive outdoors. The tree produces its own defense system, filling the wood with compounds that fight off fungi, insects, and the slow breakdown that usually destroys other materials over time, which means even when it's placed directly in the ground, where wood typically fails fastest, it keeps its structure intact for decades. What makes this even more unusual is that the protection never fades. It doesn't wear off after a few years, and it doesn't require maintenance to keep working, because it's built directly into the material itself. In a world where most products come with an expected lifespan and regular upkeep, black locust feels almost out of sync with everything around it, and that difference becomes impossible to ignore. Stronger than you expect. Durability alone would already make black locust impressive, but its strength pushes it into a completely different category, because this isn't a soft or fragile material. It's dense, tough, and built to handle serious pressure. Its hardness rating places it above many commonly used hardwoods, including oak, which means it doesn't just last long, it also resists impact, stress, and wear in a way that makes it suitable for heavy-duty use. That combination creates something rare, a material that doesn't just survive over time, but continues performing at a high level throughout its lifespan, which meant it didn't weaken quickly or lose its structural integrity under pressure. For builders in the past, that reliability wasn't optional. And when failure wasn't an option, materials like black locust became the clear choice, the wood that built early America. Before modern construction materials took over, black locust played a major role in early American infrastructure, showing up in everything from fence posts to structural framing, because its reliability made it valuable in places where replacing materials wasn't easy. Farmers depended on it for boundary fences that needed to last for decades, while builders used it in components that couldn't afford to fail. And that consistency is what built its reputation over time. One of its most interesting roles showed up in shipbuilding, where black locust was used for wooden fasteners that held ships together. And here's where it gets even more interesting. Those fasteners expanded when exposed to water, tightening the structure instead of weakening it. That single detail gave ships an advantage in durability and resilience. And in a time when materials directly affected survival, that kind of performance mattered more than anything else. The secret ability: it heals soil. What sets black locust apart isn't just what happens after it's cut down, it's what the tree does while it's still growing, because unlike most trees, it actively improves the soil around it. Its roots work with naturally occurring bacteria to convert nitrogen from the air into a usable form for plants, and that process slowly enriches the soil, making it more fertile over time. The result is something you don't usually see from a resource like this, because black locust doesn't just survive in poor conditions, it changes them, turning unproductive land into something that can support crops and other vegetation. As soil degradation becomes a bigger concern, this ability shifts the role of black locust from just a material to something that contributes to long-term environmental stability. The shift to modern lumber. As industries expanded and demand increased, the focus moved toward materials that could be produced quickly and consistently, which is where softwoods like pine took over, since they grow faster and are easier to process at scale. The problem was that these woods didn't have the same natural durability, which meant they needed chemical treatments to survive outdoors. And that's where pressure-treated lumber entered the picture. At first, this looked like a practical solution because it allowed for mass production and made wood more accessible. But here's where the shift becomes clear. The industry moved away from naturally durable materials and towards systems built on treatment and replacement. Instead of choosing wood that could last for generations, the preference shifted to wood that could be produced quickly, treated, and replaced on a predictable cycle. The business model problem. This is where the focus shifts from materials to economics. Because black locust's biggest strength, its longevity, also creates a challenge in a system built around repeat purchases. When something lasts for decades without needing replacement, it naturally reduces future demand, which means fewer ongoing sales over time. On the other hand, materials with shorter lifespans create continuous demand, supporting production, distribution, and steady revenue cycles, and that difference shapes how industries evolve. Over time, materials that fit into consistent supply chains tend to dominate, while something like black locust, with irregular growth patterns and long-lasting performance, doesn't align as easily, and that mismatch slowly pushed it out of the spotlight. Why black locust disappeared. Beyond economics, practical challenges also played a role because black locust trees often grow in irregular shapes, making them harder to process into uniform lumber. The wood itself is extremely dense, which wears down tools faster and requires more effort during cutting and shaping, and that creates a problem for large-scale operations focused on speed and efficiency. What followed was a gradual shift. Fewer suppliers carried it, awareness dropped, and builders started defaulting to materials that were easier to find even if they didn't last as long. Over time, demand decreased, supply followed, and black locust didn't disappear overnight. It simply faded out through convenience and standardization. The comeback nobody is talking about. Despite all of that, black locust is starting to gain attention again, especially in areas where durability and sustainability matter more than speed, because its natural advantages haven't changed. Architects and designers are using it in outdoor projects that require long-lasting performance, while farmers and landowners are returning to it for fencing and soil improvement. What's driving this shift isn't hype, it's necessity, because as environmental pressures increase, and resources become more limited, materials that offer both strength and sustainability stand out. Black locust grows without intensive inputs, improves the land around it, and produces wood that can last for decades, which makes it more relevant now than it has been in years. The hidden challenge of using it. Even with all these benefits, working with black locust comes with challenges, because its density, while useful, also makes it harder to cut, drill, and shape compared to softer woods. Tools wear out faster, processing takes longer, and handling it requires more skill. And for industries built around speed, those factors add up quickly. There's also the issue of consistency, because unlike plantation-grown softwoods that grow straight and uniform, black locust often grows in unpredictable shapes, which makes it difficult to produce identical boards at scale. That mismatch between the material and modern systems creates a barrier, even though the wood itself performs exceptionally well. What this means for the future, as pressure from climate change, resource limits, and rising costs continues to grow, materials are being reconsidered in a different way, and durability is no longer just an added benefit. It's becoming a requirement. Building something once and having it last for decades without constant maintenance changes the entire equation, and that's exactly where black locust starts to stand out again. It represents a shift in thinking, where longevity takes priority over convenience and resilience replaces short-term efficiency, which challenges the systems currently in place. Instead of relying on constant replacement and chemical treatments, it offers a natural approach that aligns with long-term sustainability, and that difference is becoming harder to ignore. Nothing about black locust itself has changed, it hasn't been redesigned or improved, and it continues to offer the same strength, durability, and resilience it always has. What changed is how often we choose to use it, and that decision shaped the materials we rely on today without most people even realizing it. And this is where the story takes a quiet turn, because the gap between what we use and what we could use keeps getting wider, especially as older materials with proven performance fade into the background while newer options take their place. The result is a system that often prioritizes speed and availability over longevity, even when the long-term costs end up being higher in both money and resources. In many cases, people aren't even aware that alternatives like this exist, which means the decision is already made before the choice is ever considered, and that lack of awareness keeps the cycle going. Over time, familiarity replaces performance as the main factor, and materials that once defined durability slowly become a footnote instead of the standard. If a material can last for generations, improve the environment, and require almost no maintenance, it raises a bigger question about what else has been overlooked and how many of those choices were made for convenience rather than performance. If this made you see things differently, subscribe and stick around, because there are more stories like this that most people never hear about.